All right, let's dive into something that sounds like it's straight out of science fiction but is actually changing the way we think about code. We're going to connect the absolutely bizarre world of quantum physics with the logic you write every single day.
So let me just start with this question. What if your code wasn't just a bunch of static instructions? What if it could actually feel what's happening in other parts of the system instantly?
I mean, really think about that. Imagine your functions and data models are so in tune, they're practically whispering to each other across different modules, maybe even across totally separate repos, with no direct hard-coded link between them at all.
You know that feeling when you fix one bug, and then another, completely unrelated problem just disappears? What if that wasn't just a happy accident? What if it was a sign of something much, much deeper going on? This isn't fantasy. It's a new lens for looking at software. Okay, so this whole idea is called vibe programming. And to really get it, we've got to start with one of the weirdest, most mind-bending, but absolutely proven concepts in all of physics. So, on one hand, we have actual quantum entanglement. You take two particles, you link them, and you can separate them by billions of miles. The instant you measure one, the other one knows. It's like a fundamental law of the universe. And on the other hand, we have the metaphor, code entanglement. This is when parts of your system are connected, implicitly through their design, so that a change over here causes a positive, unexpected boost way over there. This whole quantum connection thing was so bizarre, so completely against all common sense, that even Albert Einstein couldn't get his head around it. He famously called it spooky action at a distance. He was just convinced it couldn't be real.
But here's the thing. The universe is just weirder than we think. After decades and decades of debate, it all came down to a series of experiments in 1982 by Alain Aspect. And they proved it. The science was settled. The spooky action, it's totally 100% real.
So, how do we take this cosmic strangeness and actually make it do something useful in our code? Well, it all starts at the very foundation of any app, the data structures.
See, a really well-designed data structure is where the vibe begins. It's like a world-class orchestra. The musicians don't need the conductor to tell them every single note to play. They listen to each other, they feel the music, and they just harmonize. Great data models do the exact same thing for your information.
If you think about data like waves, it just clicks. Bad schemas are like mismatched frequencies. They clash, they create static and noise, what we call bugs and weird behavior. But elegant schemas, their frequencies line up perfectly. They resonate, they amplify each other, and you get this beautiful, stable, coherent system.
All right, so we've got the data sorted. Let's move on to the active parts of our code, the functions. This is where the orchestra really starts to cook. Resonant functions. They're kind of like a great jazz band, right? The saxophone player throws out some wild new riff, and the drummer just knows what to do. There wasn't a command, there wasn't a script, it was just an intuitive reaction based on a shared understanding of rhythm and structure. In code, that's what happens when your functions are clean, predictable, and do one thing well.
And get this is not just some nice philosophical idea. It has a massive real-world impact. Way back in 2003, some improvements to the scheduler in the Linux kernel just happened to vibe with the system's modular functions. The result? They slashed system latency by a staggering 50%. That's pure emergent performance, just from good resonant design.
So, if this amazing vibe can just sort of happen on its own, the next question is obvious, isn't it? Can we actually engineer for it? Can we be intentional about this stuff? And the answer is absolutely. Yes. And it's probably way more familiar than it sounds. It really just boils down to a few core practices you probably already know. First, name things well. A variable called user profile instantly sets a clearer vibe than data object. Second, use interfaces. Focus on what a piece of code does, not how it does it. That creates loose coupling, which is key. And finally, test the whole system, not just the little pieces, to see how they all play together.
And the data proves this works. A 2024 study of Google's gigantic monorepo found that these principles led to a 40% drop in bugs. Another study showed that just naming things well boosted readability by 40%. And check this out. A real-world refactor from old-school jQuery to modern React hooks, a 60% drop in bugs. This stuff really, really works.
So if you're sitting there thinking, okay, this sounds cool, but where's the blueprint? You already have it. It's the solid principles. When you really look at them, they are a guide to engineering for this vibe. Every single one, from single responsibility to dependency inversion, is about creating clean, decoupled, cohesive modules that can resonate with each other.
Let's make this super concrete. Think about a simple to-do app using something like Redux. A user clicks a button. That fires off an action, like add_item. Now that action doesn't go and tell the UI, hey, you need to change. Nope, it just vibes with the central state. The UI is just listening for changes to that state, and when it feels the change, it automatically updates itself. That's a perfect example of resonance.
So where is all of this headed? If we really lean into this way of thinking, of building software, I mean, what does the future even look like?
Well, it leads to a future where software acts less like a fragile machine and more like a living thing. We're talking about complex systems that can actually heal themselves, that can evolve, maybe even anticipate failures by sensing these tiny dissonant vibes in the network before anything catastrophic happens.
But of course, this incredible power brings up some really deep questions for us, doesn't it? If our systems become so autonomous that they can debug themselves in ways we don't fully understand, what does our job become? How do you guide a system that's starting to guide itself?
And that brings it all the way back to you and the code you're going to write tomorrow. Is it just a list of rigid commands? Or is there a harmony to it? Does it have a vibe? So here's the challenge. Take this idea and try it. Fork a repo, refactor it with these principles, and just see what emerges. You might be surprised by the magic you find.